remember too, as if you don't have enough to remember, that you can go into the student version so that you can see where people are and you can freeze them. So if you want to freeze them at any particular point, you click on pause here, and then you can pause it from, oops.
It's so crazy the rain out there. I'm sorry, didn't mean to.
You can click on pause here.
You're on.
Sorry, click on pacing, and then you click on the first one, and then you want to restrict it, you can just click on the ending screen. So that's how you use the pause button. So when they're on number 7, you want to include number 7 there, but encourage them to go back and do number 6 and number 7. Go back and play with those. That's the whole point of that particular ability of having them write what they're thinking and not just watching you play around. All right, so we did those two. Let's move on to the hardest one. This is, now look at this. I got parameter C here and I got f of b, so I got to change parameter C to make it parameter b in slide 9. I'll fix both those things before I send this to you. So the idea here is, as we look at this, what do we see? Well, you know, when you're subtracting, we're just assuming that b is positive. When you're subtracting a function, it goes to the right, and when you're adding a function, it goes to the left, which seems counterintuitive, but people just remember that and they can't explain why that is. So let's see if we can once again support this idea from a pointwise perspective. We want to look at, let's start out with the easiest one when you've got b as a positive number. So if I have, and then also let's move this x over here somewhere. Okay, let's move it to 6. So what we're doing here is we're saying, and I'm going to move b to be an integral here. What we're saying is that we start off with a number like 6 for our x or our p. And we're saying what we really are doing is we're taking the value of 6, we're actually subtracting 3 before we go up. We're subtracting 3, we're saying what's the value of that function on the red, the old function. We take that value, but we say it's a function of our new x, so it gets moved back to the right. So why does it go to the right when it doesn't even look like it's going to the right when I have that pointwise perspective on, right? But again, let's hide that for a second. So what's happening? Why does it appear to go to the right when there's a pointwise perspective? Because the x is actually, you're starting at x, you're subtracting a number. But you can see from that, looking at that point, what you're really doing, right, is you're looking at this old point, and as x increases, this number increases because the new target y value increases because the function is increasing over here. But it's getting that big number is getting translated over here. Now, if we go to the negative side, it appears to go to the left. It also appears to me that we're going to have to shrink this down. So pull this down. Again, using the shift key. So we can see what's going on here. Okay, let's move our x value over here. Okay, so maybe over here. So now when we're subtracting a function, okay, now remember it's x minus negative, right? So really what we're doing is adding. So why does it look like it shifts to the left? Because you have a function here, x, you're subtracting a negative, which means you're adding. So you're going in this direction. You're taking this value, but you're shifting it to the left because that's where the x is. So the reason it looks as though when you add a function, it shifts to the left is because you're starting here, you're adding something, but then you go back because this is a function of the original x. Okay, that's kind of a mouthful. Let them play with it. So go to the next thing. You can ask them to play with this idea. Try the idea of picking an x and subtracting 2. So given this function, find what this x minus 2 would look like. You know, they might just say, well, you're subtracting, so I'm just going to shift it 2 to the right. And in a sense, that's correct. You know, they can kind of graph it like that. But what would be nice is if you could say, can you pick a few points? So let's pick a few points, all right? Let's take a look at, let's say x is 0. So if we subtract 0, we get -2. Well, what's the value at -2? It looks like it's about negative, I don't know what that even is. It's 5, 10, 15, 20. So it's like -6, right? Well, actually, it's -8. So if we say it's -8, well, what happens is we take that -8 and we shift it here, but it's still a value at x. Let's take another one. Let's take 1. Okay, so, well, all right, we'll take 1. 1 squared is 1. Okay, so if I stay here at 1, and I'm going to take 1 minus 2, that's -1. So -1 has a value of -1, and that gets translated over to the, what did I start with? Here, so it should be there. Okay, so try to tell them to do it with a pointwise perspective rather than just moving the whole thing, because that's what you remember. Yes, it's going to come up with the same answer. Yes, it's a little slower, but it helps them walk them through this idea of a translation. All right, so now have them write if you want to. And again, you can have them pause. So let's see, we want to restrict there. All right, let's do pacing again. We want to stop that pacing. You might want to play around with this. Having them graph, having them go over here, and playing around with these last 3. So here's one more change I made, is I added one more function. Well, I added this one. Or no, we already had this one. Sorry, we already had this one. This one is, where are we here? No. I told you about that one. Okay, now we want to think about a horizontal shift. So you know that you want this point 0 to go over here to -2. So you can say, yes, I remember if I want to move it to the left, I add. But why is this happening once again? So remember, you're thinking about a shift going this way. So what you're saying is, if I start at -2, what value, I want this to be a 0 right here. Well, I know that the y value is 0 at 0. So if I say -2 plus 2, that gets me to the point where this is. Let's try another one, right? Let's see if we can hit this point here. This point here at -1, 1, right? So what I want to do is, I can see that there's a 1 here. So this is 1. So if I am at -1, how do I get to the 1 where the value is up here? Well, I add 2. So I go 2, then this function, or this value, gets translated back here. Okay, so if I think of this as g of x is equal to f of x plus 2, okay, that's why it works that way. I'm taking a function, let's say I take 0, if I add 2 to it, I would be over here. Well, that value is 2, and that's why that number there gets translated back there. If I want to see this vertex move over, I say to myself, I am at -2, I want that to be 0. Where is the 0? The 0 is here. So how do I get from -2 back to this, the x value of 0? I add 2. Hopefully that's a little bit more of an explanation for you.